Hi everyone. So today, this is going to be a pretty quick video, I think. We're going to be talking about the corrosion lab. So in the corrosion lab, we set up an electrochemical cell, and we have copper as our kind of positive terminal connected to our red alligator clips, initially kind of your cathode type material. And it's connected in a basically a seawater 3% salt solution at room temperature. And it is connected to a variety of different metals. So you're going to connect that to at the negative terminal, your black alligator clips, basically where the anode initially should be in the correct kind of positioning. So we're going to test and measure what is the resultant EMF, the electromotive force, or essentially your potential in volts for comparing copper to zinc, silver, aluminum, gold, brass, iron, magnesium, and platinum. So we are going to, again, keeping always that copper in your, in that kind of positive terminal, the red, that red top positive terminal alligator clips, and comparing all these metals, keeping that in the negative terminal. And we're going to see what is the voltage, and we're kind of going to rank in terms of electronegativity, and we're going to kind of describe where are electrons flowing in this lab. So that's kind of the charge that you're kind of tasked with in your technical memo. So you want to kind of think of a scenario where you need to kind of for some reason you need to kind of investigate where are the electrons going to flow, what material is going to corrode, what material is not going to corrode when in contact with copper in this kind of aqueous seawater solution. So that's what you want to kind of write about in lab. But again, today is more just analyzing the data, and we'll talk more about kind of the writing in a separate video or kind of not offline because we're always online, but in our kind of lecture time and office hours. Or in the lab as well. So first things first, let's do an example and look at the data set that you're going to be looking at. So let's grab, to start with, let's just grab iron, for example. So I'm going to copy, I'm going to paste this into my mathematical notebook, and I'm going to import as usual. And luckily for this lab, it is really pretty straightforward in terms of what you need to do here. So data, and this is your data. This is your data in volts. So the only thing here that's annoying is all these parentheses, so I'm going to get rid of all of them and flatten, and that's it. So this is your data. You measure it. Let's call this FE data, FE dat. So looking at FE dat, let's look at the length. So the number of data points we gathered is this, 101. Let's look at the mean. So one of the things, I mean, again, you're taking multiple measurements. So what you want to plot as your resultant, EMF or voltage is the mean of FE dat. That is just going to be 0.33 volts. So that is your mean of iron. Now, whenever you give a measurement, if you've made multiple measurements, you want an error bar associated with that. We're going to deal with standard error. So the error in FE, standard error is basically taking the standard deviation of your data set, FE dat, and we're going to divide by the square root of the length, so the square root of the number of samples of FE dat. So it's 101 measurements. Basically, we took 10 samples per second for 10 seconds in this lab, and that's your error. So it's going to be this value plus or minus this. So very, very, very small error, but again, error is still present in this measurement. So that's what you're going to do. That's it. So you have all the data files. So for brass, aluminum, zinc, magnesium, platinum, gold, Ag, you're going to look at kind of, so we have a positive voltage. So where are the electrons flowing if we have kind of this positive voltage? Well, we know that electrons are flowing from, if it's positive, are flowing from the anode to the cathode. So that kind of makes sense, right? Because what is our electronegativity of copper? Electronegativity of copper. Like a second for you to look it up in your chart. So electronegativity of copper is 1.9. Electronegativity of iron is what? 1.83. So exactly, copper should grab those electrons. So this makes sense when you're kind of thinking about it in terms of electronegativity. Now it might be different for 1.95 for copper. What about gold? 2.54. So we might expect a negative value there because we set up our gold in that kind of negative terminal, the anode position. If we're pulling, but again, it's all about who wants to grab the electron the most. So if they pull electrons, if gold is one pulling electrons, you'll measure a negative voltage. And then again, you know what happens. So if you're giving away electrons, you're corroding. If you're accepting electrons, you are not corroding. So that's basically it. So again, read lecture 8. You could look up in the OER as well. But this is the gist of analyzing this data set. So last lab, congrats, you've made it through. Again, if you have any questions or you're writing the technical memo, please let me know. Get started early. And yeah, short video today. Gear up for that final. You're almost through, and summer is coming soon, and hopefully we'll be kind of out of this mess as the temperature warms up. So thanks, congrats for getting through the lab, and have a great day.